Okay, friends, so just two further examples of the absolute value inequalities as they get a little bit more complicated. So here we've got a word problem. And so it's going to be important to figure out, harking back to that idea that x minus the center, the absolute value is some distance away from the center, equals whatever the distance. So x to the center is some range. So we're going to try to think about where the center is and where the range is. So if we think about this, I like to think about things in two different colors. It helps me out a little bit. So if I think about looking for the center when I'm reading through this, Amanda is apartment hunting in a specific area. She discovers that the average monthly rent is $600 a month, but the price could differ as much as $225. Well, so the center, the average, what's in the middle is the 600 there, and we could go 225 either way. We could go as much as 225. So that's going to be less than or equal to, right? It's going to go up to and include. So if we think about this, we've got x minus 600 could go up to and include a difference of $225 a month. Okay. And if I think about it on the number line, I think it should be a range, so it makes sense that it would be less than or equal to, because I want it to be an intersection. Okay. So solving this, I'm going to just split it into the two cases. So I've got x minus 600 is less than or equal to 225. And the other side, x minus 600 is greater than or equal to negative 225. Again, remember to flip the inequality in the negative case. So solving gives me that x is less than or equal to $825, or here x is greater than or equal to 375. I just want to check that arithmetic. 75 plus 25 more is 400, plus 200 more is 600. Okay. So if I were to think about my number line, x would go, the smallest possible value would be 375. The largest possible value would be 825. That seems to make sense. So again, I can write it in two forms. I could say x, there exists an x such that x is greater than or equal to 375 and less than or equal to 825. Okay. Or in my interval notation, I've got a inclusive ending at 375 and another inclusive ending at 825. Okay. So one last one, I just want to make sure I've sort of showed you one of each type. This one's just a case of solving. And so I'm just going to run through the steps. I'm going to go through pretty fast here. You can always pause and go back if you need to, if I go too quickly for you. Okay, so first I'm just going to rewrite the problem underneath the graph here so that I've got room minus 7 is equal to negative 5. Okay. First thing I want to do is get this absolute value by itself, so I'm just going to add 7 to both sides. So that gives me the absolute value of 2x plus 2 is less than or equal to 2. So splitting, I get 2x plus 2 is less than or equal to 2. That's my positive case. And 2x plus 2, flip the sign, is greater than or equal to negative 2. So solving is going to give me 2x is less than or equal to 0, so x is less than or equal to 0. And solving here, I get 2x is greater than or equal to negative 4, and so dividing both sides by 2, x is greater than or equal to negative 2. Okay, so looking back up here, I expect this to be a intersection, an inclusive range. So here I've got x is smaller than or equal to 0. So I'm just going to get, do this maybe in highlighter. So smaller than or equal to 0 and larger than or equal to negative 2. And there we go. That's our connection. And to write it out for you, we've got there is a set, there exists an x such that x is greater than, x is greater than or equal to negative 2 and less than or equal to 0. Or in our interval notation, we've got a range from negative 2 to 0 with inclusive endings. Okay, I hope all of that was really helpful for you. You're going to spend class time working through some of these problems. So I hope that all is well. Email me if you have any questions. Thank you so much.